Hello and welcome to another Advent of Code video. We're looking at day 16 today, which is quite a long one, so I'm just going to jump into it, not waste any time here. Okay, so the problem for today is another ticket parsing problem, which I think we already had one, but we have another one. And our input is a series of 3 chunks here. Let me open up our parsing file. That's what we're going to do first. You can see that we have a series of field ranges. So this defines what a field could be. So, you know, that it could be the numbers 1 to 3 or 5 to 7 for class, row, and seat, etc. And these are inclusive, so that's important. There's also another line, which is your ticket, which is tickets are a series of integers that are comma separated. And then there are nearby tickets, which are the rest of them here. And I think most of this problem is a parsing problem, and the rest of it is a series of steps to get to the final answer. Part 1's pretty straightforward. Find the sum of all fields that aren't valid for any field. So for each of these numbers, so like take 7 for instance. 7 is valid for this field, so that's fine. 3 is valid for this field, so that's fine. 47 is valid for this field, so it's fine. 40 is as well. 4, for instance, is not valid for any of these fields. So this is one of the numbers that will be in your eventual sum. And for part 2 gets a little bit more complicated. I actually don't have a sample input for part 2, and there wasn't one given with the problem, so we're going to be working with my full data here, and I'll show you kind of how I debugged it along the way. But the first step is you're going to discard any of these nearby tickets which have any invalid thing. So in that case, you know, this line would be completely out. Then you have to figure out which fields, which slot here is which field up here. So you gotta figure out which one is assigned where. And then finally, you'll answer the multiplication of all of your fields that start with the word departure in your ticket. So the first step is like throw out any invalid tickets. The second step is figure out where the fields are. And then once you know where the fields are, you can multiply all the departure steps together. We, of course, don't have departure here because this is the simple example. But anyway, that's the problem. Let's start by parsing this, and we're going to be parsing this into 3 parts here. Note that I've used type aliases here. I think I have a video about this. Oh wait, no I don't, it's not out yet. Oops. Anyway, there will be a future video on my channel which goes more into detail about type aliases, but we're just using it to save some typing here, so that typing, like keyboard typing. Anyway, the way I decided to parse this input, at least this part here, was with regular expressions, just because that's what I tend to reach for. You could, of course, do this without regular expressions by using some split and such. But I found that it was easier to do, let's see, field re equals re dot compile. And I didn't put this in my cheat sheet, so we're doing this one live. I know that there can be spaces in here. This is actually a problem that I ran into when I was doing my parsing, because there are spaces here. So we need a capturing group that's going to capture non-colon characters. So we'll capture everything up to here. Then we're going to capture colon. Oh, I always like to put the the end, beginning and end parts here as well. And then we're going to match a digit or a number followed by a dash, followed by another number, followed by a space or space, and then a number, another number, dash, another number, $. I think that's our field regex, and so we'll use that to parse these here. For these lines, it's basically just going to be grab the second line and split it, and for these lines, it's going to be, again, grab the second line and split it. So let's do that next part here. So we're going to have fields s, my fields s, my ticket s, and nearby s equals s dot split back end. So this will split by this blank line in the middle. Let's do the fields parsing first, since that one's going to be the tricky one. Fields equals a dictionary for line in fields s dot split lines, match equals field re dot match, line assert match is not none, just to make sure that we actually matched it. And then we need to assign into fields. This will be group 1, and then 2, 3, 4, 5. Fields. The way I'm representing this is as a string mapped to a 4 tuple of integers. These are B2 internal ranges in here. I saw some others represent this as an actual range object, but I found, I feel like the 4 integers is a little bit easier to understand. But anyway, fields match 0. Actually, we're gonna make this variable name shorter, so just for the sake of the video. Equals int, should be match 1. Int match 2. Oh boy. Int match 3. Int match 4. And int match 5. That should get all of those fields out of there. So that's parsing that. And we need to parse my ticket as well. Note there are 2 lines here, so we need to do my ticket equals int x for x in my ticket s dot split lines 1 dot split comma. So I am splitting this into 2 separate lines, then grabbing the second line and then splitting that on commas, and then converting each part into an integer. A lot in one line. I might split this up into multiple lines if I was going to write this code for real. And then finally we need to do nearby tickets. And so what I did for that one is ticket lines equals, or at least I think I did. I don't actually have this code either. Nearby s dot split lines. And then nearby equals list for line in ticket lines 1 colon. And you might take this and make it into a function here. Actually, we can just do that, right? Parse ticket s stir to list int. And we would do return int x for x in s dot split on a comma. And then we could use parse ticket here. Parse ticket my ticket s dot split lines 1. And that, simplifies this up a little bit, saves us a little bit of typing here. Then we can do parse ticket line. And actually, I would probably convert this into a list comprehension by saying nearby equals parse ticket line for line in ticket lines 1 colon. And again, we're using 1 colon to skip the header row that we got here. And finally, after all that, return fields my ticket and nearby. And hopefully we typed this properly. Parsing. Dict has no attribute split lines. This should have been fields s. Keyprint is not defined. Okay. And what do we get down here? We got class 1357. That looks good. 61133 44. Yep. 1340 45 50. Yep. 7114. Yep. And those look correct as well. Very cool. So that's the parsing part. A little bit complicated, a little bit of extra code here, but hopefully that's not too bad. All right, let's move on to part 2 now, or part 1 now. Yeah, skipping straight ahead to part 2. Bammy part 1.py. I've copied in that same output here. Note for part 1, we don't actually deal with my ticket at all. We're just dealing with the fields and the tickets. Now, what we want to do here is we want to sum all of the fields that aren't valid for any of these specifiers here. So what I did is I looped over all of the numbers and all of the tickets. So for ticket and tickets, for and in ticket. And then we got to loop over all of these for B1, E1, B2, E2, beginning 1, N1, beginning 2, N2 in fields.values. Again, we don't care about the name of the field here. And we need a final total. And we want to say if not B1 less than or equal to N less than or equal to E1, or B2 less than or equal to N less than or equal to E2. So if they are not valid for this field, oh, actually, we can do this the other way around. So if it's valid for a field, we're going to break out of this loop, and only if this loop exits normally, we're going to use a for else here. I did a video on for else. I will try and remember to link that in the description. So I'm actually going to flip this here. So if we match some field, if some field is correct, then we're going to break out of this loop. Otherwise, we are going to add it to our total. Total plus equals n. This only happens if all are invalid. And then finally at the end, we will return total. And I believe that's part 1. Cool, and we get 71. So that's part 1. Part 1 I thought was pretty easy. I actually got points on this because I solved it so quickly after midnight. But part 2 is where things get really, really complicated. And we're actually not going to be able to reuse much of this code there. But I will copy this part to part 2. So let's move on to part 2 now. And in part 2, we have a series of tasks. And I'm going to implement them one at a time and kind of print the intermediate results and talk about how to get from that intermediate result to the end of it here. So let's start with that for loop we had here. So the first thing that we need to do is discard all nearby tickets with an invalid field. So what I did here is I made a valid list. And I looped over all the tickets and looped for all the ends in the tickets and looped over all the fields. And we need to find all of them are valid. All of them that are invalid, I guess. And so what we really want to say is if all of the ends are valid for any of the fields, then we're going to do valid.append ticket. So this is, well, we need to actually fill this part out. We didn't fill this part out yet. But we need to say that any of the fields for all the fields is valid. So we need to say all and then any. Let's see. B1 less than or equal to n less than or equal to E1, or B2 less than or equal to n less than or equal to E2. So this is our condition that we had before, and we're asking here if any of if this is true for any of the fields for all the tickets, then we know it's a valid ticket for all of the integers in it. So a bit of a complicated line here. I actually wrote this as several nested loops in my solution. So my solution looks like this, if you want a comparison here. But I felt that this is a little bit easier to explain. So here's what my solution looks like for that. So what I did, I have the parsing intermixed because when you're trying to go fast, you don't split it up. But again, like I had, 4 ticket in tickets, 4 n in ticket, loop over all these, and I had break, else append. This meant, if it was an invalid ticket or an invalid n, then we broke, and if we never broke for an invalid n, then we appended our ticket. So that was my logic there, but a little bit more complicated than we needed. Okay, at this point, given the input that I have, which actually I forgot to copy that. Day 16 input.text to dot. For this, let's actually print len of valid. If I did this correctly, we should see 190 valid tickets here. And we started with something like 230, if I remember correctly. Part2.py. I'm so confused. How did we print these things here? This is from parsing. Where? What? Oh, I know why. This is, I imported the parsing code here, and the parsing code has a side effect down here. So let me just comment that out. It's like, what is going on here? Okay, there we go. So we were able to filter down to 190 valid fields here. And the none here is just because my compute function is currently returning none. Okay. Once we have our valid fields, the next step of this is to figure out which fields are in which slot. And so what I did for this is I built up a list of, or a mapping of sets for each position and figured out what possible fields were there. And for that, we can do a default dict. I actually did this in a one-liner in my solution, but I feel like the default dict will make a little bit more sense here. So possible at pause equals collections.default dict set. And again, well, here's default dict again. And I looped over each possible position for position in range len valid 0. So for each possible field position, we're looping here. And then we need to loop over every single every single range and every single ticket. And if they are all valid for that, then we append that field. So we want to do for key, comma, B1, E1, B2, E2 in fields.values. So looping over all the fields. And then we need to loop over all the tickets for ticket in tickets, for ticket invalid. I made that mistake. And we need to check if all of those are valid. So one thing that we can do here is we can just break out if it's not valid. And so if ticket pause, right, ticket pause is going to get us our individual intermediate part. If B1 less than or equal to ticket pause less than or equal to E1, or B2 less than or equal to ticket pause less than or equal to E2, we know that that is good. How do I write this? For ticket invalid, if this is true, actually let's say if this is not true. If this is not true, then we are going to break. Otherwise, this means here, you know, all tickets past that field. Then we can do possible at pause.add key. So that'll add this particular key into here. And so that should populate up our possible at pause. Now note, the way that I wrote this was, was all one list comprehension here, or one dictionary comprehension. And I felt that this loop was a little bit easier to read. But what I basically did is, you know, took this for loop and combined it all into one comprehension here. So, and I used all in place of this for else loop here. But I know, I think this is a little bit easier to understand than that. Okay, so once we've gotten to here, print, import pprint possible at pause, we should have a mapping to a bunch of different fields. Too many values to unpack. Oh yeah, this is supposed to be items. Default dict has no attribute add. All right, possible at pause, pause. So we have to index into here. Okay. And this is basically what my problem looked like here. So I had a bunch of fields, and they had a bunch of, you know, assignments, and some fields were valid for all sorts of them. But if you look here, we have one field that we know exactly what field position that is. We know that type is always this position 16. And so we can use this knowledge to kind of reduce down the rest of these fields. So like, if we know type is 16, then we know type can't be 17, so we can eliminate this from the set. We know it also can't be 15 or 14 or any of these other ones. And so what I'm going to do is incrementally remove type from each of those. And I did this in a really crappy way. There's a much more elegant solution with a loop. I'm going to, you know, leave the elegant loop solution to you and show you how I did this. And we're actually just going to copy and paste some code, and I'm going to walk through it. Because... yeah, I don't feel like really super explaining. This is kind of hacky, and I'll show you some parts where it's not so great. But basically what I did here is, let me actually change the variable names so they match up. Possible at pause. Yeah. So what I did here is I had a while loop, and I slowly destroyed this mapping type here. As I assigned out the fields, because this is just an intermediate value. I didn't really care so much about it looping past this. But while this existed, I looped through every item inside of it. This is the kind of the slow part. Like, this is where sorting this based on the length of the second item would be helpful, because then you could just, you know, eliminate them really quickly. But I didn't do that. I just brute forced this because, you know, this isn't the slow part of the problem. But I looped through everything in this possible at pause mapping. Note here that I'm using tuple. I am serializing these values to a sequence so that I can modify the mapping as I'm iterating over it. Again, you wouldn't have this problem if you just sorted and ran through the sorted list. What I'm doing here is if the values is 1, so if we, found a case like this one here, we know that that one key is assigned, so we can pop that key out and we can assign the final positions, which is going to give us our mapping from our key name to our position number. We can assign that, remove it from our list, and then we can discard that key from all the other mappings. So we can go in here and say like, you don't have type anymore, you don't have type anymore, you don't have type anymore. Basically filter out all of these other sets so they shrink down to the right value eventually. And so that's what this part does here. And then after that, we should be left with pprint positions. We should be left with just a list of our positions here. So this gives us all of the, where the fields live in our actually mapping. And the ones that we care about are these ones here, these departure ones. And finally, we need to multiply our values in our ticket against these. And so what I did is ret equals 1, and then for kv in positions dot items, if k dot starts with departure, this is the part that they wanted in the problem. If the key starts with departure, then we know we need to multiply into our final value. What did I name the ticket? Just ticket, I guess. Oh, but that means we probably clobbered it. Let's call this my ticket. Because I used a local variable also called ticket, so I clobbered over that value. So then we need to do ret times equals my ticket v. Is that simple? Yeah, it's that simple. So we're grabbing out the position of this here. And then finally we return ret. And I guess I'll show you what my answer was. This was my answer that I got for the problem, but it'll be different for you. Let's talk about algorithmic efficiency for both these problems as we do. Is this going to fit on the screen? It kind of is. I'll bump this down a few lines so you can see all the code. Okay, let's talk about algorithmic efficiency here. So we're looping over every ticket here. This is ON. ON. We know that the tickets are fixed size. We know that in my particular input, they were 20 wide. In the sample input, they're 3 wide. So this is O1. And we also know the fields are bounded by the same value. So this is overall O1. It's actually O10, but constants end up being just a constant. And so overall, this first algorithm is ON. Part 2 is a little bit more tricky to look at the algorithmic efficiency. However, again, like this for ticket and tickets, even though we're doing, loops in here over the number of fields, and over the fields in the ticket, this is constant time and this is constant time. So this is ON. This is bounded on the length of a field. So this loop is constant, doesn't factor in. However, we're looping over tickets again, so this is again ON. But the constant is big here, so it's 20n, for instance. And then this is ON also, but it's a little bit tricky to see. And this copy is actually, this is less than ON. This is O20 again. This copy is also O20, but again, like this doesn't play into the final value. It's overall order n, even though we're doing a bunch of other work here because the constants, get factored out. But anyway, that's part 1 and part 2 of day 16, which, oh my goodness, this was quite the long problem. Hopefully this was helpful, and I will see you for the next day. Peace.